we'll be going over binary tree level order traversal, which is LeetCode medium 102, and we are given the root of a binary tree. We just need to return the level order traversal of the node values from left to right, level by level. So that is a standard BFS problem. That is a level order traversal. So we are given 3, 9, 20, and null means that the children of 9 are null, and 15 and 7 the children of 20, right? So we just need to return level wise traversal. That is, first 3 would come, then 9 and 20, this level would be covered, and then finally 15, 7. So we need to return it in the form of a vector of int type. So for this, for the final example, we have root is 1. So this is the answer. So it's a simple problem. We just need to perform standard BFS. So we store our answer in the vector of int type. So we check if root is null, then we return answer, and we make a queue which is basically of tree node star type, where we will store the node in our queue, and we push the root initially, q dot push root. Then we check while queue is not empty, n is equal to q dot size. Basically, n is the number of nodes in that particular level. So we store vector of int level. So we'll be storing all the node values in that particular level. So for example, for the first level we'll have 3. Then in the next iteration we'll have 9 and 20 in this level, and then finally we have 15, 7 in the level. So for int I is equal to 0, I less than n, I plus plus. Node is equal to q dot front, and we have extracted the value. Now we pop it out from the queue. If the node if node's left is not null, that is, if the left child of the node exists, then we push that into the queue, and if the node's right child also exists, then we push that into the queue. And finally, level dot pushback node value, that is, in level we are pushing the value of the node, right? We're not directly pushing node because node is of tree node star type. Queue is basically storing that, so we need to take the node's value here. Node is of tree node star type, right? So that is why node value is taken and pushed into level. And finally, after one level has been completed, we push the answer into push the level into the answer, that is, like, so that it comes in this format, right? And then we finally return the answer, which is in vector of int type answer format. And let me submit and show you. So yes, this has been accepted. Now let me go over to binary tree zigzag level order traversal for you. So this is also similar problem. So we'll be covering that. The only difference here in this zigzag level order traversal would be that we have to traverse the nodes from left to right when we are going from basically on the even levels we are traversing from left to right, and for the odd level we will be traversing, that is for level equal to 1 and 3 and so on, we'll be traversing from right to left. And for again the even level, that is level equal to 0 to 4, we'll be traversing from left to right. So that is the only difference here. So how do we solve this? We basically take the same example and the same basically steps, vector of int type of data structure, and we store the result here. If root is null, then we return result, and we have a queue of tree node star type where we will be storing all the nodes that we have pushed in. So this is for BFS, standard BFS, as I just discussed. And we push the root, and now here the additional step is basically, since we are going to alternate between left to right traversal and right to left traversal, we will have to have a flag which would basically reverse the order of traversal for each level, right? So bool flag is equal to true, so for reversing order, while the queue is not empty, n is equal to q dot size, which is number of nodes in that level, and vector of basically again we store each row level in that tree. So vector of int row, right, we store this, and for int I is equal to row, we'll be storing each level, right? And for int I is equal to 0, I less than n, I plus plus, we are traversing over each node in that particular level. So node is equal to q dot front, and popping it out from the queue. Now position to fill the node's value, we have to decide that. So index is equal to I. So index would be equal to I. So let us just show you here. So the index would be equal to I in case the flag is positive. That is, if we don't have the reverse order, then index would be normally placed, right? But in case we have the flag as false, that is for reversing the order, right? So if the flag is false, then we'll be traversing from right to left. So we'll start storing in the list, in this row list or row vector, from the reverse, that is from right to left. So that is how we're starting from size minus I minus 1, right? So we are doing this. So if flag is true, we store in the row in normal order. That is, if flag is true, we store it for starting from index I. Otherwise, we start storing in the reverse order. So we store row of index in node value. So this is the only key part here. Row of index, we store the node's value, right? And we check if the node's left child exists, then push the left child, and if the node's right child exists, push the right child. And after each iteration, or basically after each level that we have covered, we alternate the order. So in the first level we are going like this. After covering level 0 we go like this, right to left, and after covering level 1, after going from right to left, we again start from left to right, so we alternate the flag at each level, and finally we push the row in result so as to get our zigzag level order traversal. Let me submit and show you. Okay, so we're getting a problem here. So the size, basically size should be n, right? Sizes are n, so let me submit that, because we have declared n as the size, right? So n minus 1 minus I is the answer. And yeah, no wait, runtime error we are getting. So I think we have to submit it, basically specify the length of that row. And yeah, now it has been accepted. So yeah, that's it about the video.